Welcome back. The objective of this video is to complete multiple transformations of the same graph. Here in example 5, they ask us, they give us the function is continuous as defined from negative infinity to infinity, and then they ask us to use the graph to complete the table of h. So based on the graph, we go back and we plug in our values for y, and as best we can, we get the red values for y here. It seems like when x is negative 2.5, y is about negative 6, and so forth. So I've taken the liberty to complete that table and plot those points. And also what I've done here in the next few problems, I've recopied that original graph onto our each problem in red. So you've got exactly what that graph looks like. And then we'll go ahead and do transformations of the red graph, and we'll rewrite the new one in blue. So in sample A, we have y equals the opposite of h of x. Well, this is a reflection across the x-axis. So any point that's above the x-axis is going to go below, and any point that was below the x-axis is going to go above it. So it is easy to take some of these points and replot them as such. Let's see if I can do that as something like that. And then we can go ahead and graph our function. So I plotted kind of reflecting points here, and I went ahead and I graphed from here at -1 for x and down around -4. I've graphed in the opposite direction of the red, and then followed, and I passed through those intercept points where the zeros are and traced my graph. So our ordered pair here is then just x comma the opposite of y, so that would be a reflection across the x-axis. In B, they want us to do the absolute value of x, which means that all our positive x's are going to stay, or our positive y's are going to stay the same, but our negative y's are going to become positive. So our ordered pairs here are going to be x, the absolute value of y, and then all these negative x's now will become positive x's. These negative x's down here, let's see if I can reflect this one to its appropriate location. And that will look something like that. And our graph will look like that blue one. So now we have done sample B and the absolute value. In sample C, y equals we're going to input the opposite of the original x. Y equals h of negative x. So this is going to be a reflection across the y-axis. All our ordered pairs here are going to be negative x, y. So our positive 1 here, if we were going to input -1, so that's going to reflect across. This 4 here is going to reflect across to 4 here. This -2 actually is going to reflect across to +2. So this point down here is going to reflect across, what is that, 3, -5, so -3, -5 will reflect across. This point here is going to reflect across. So that's going to give us our new graph that's going to look something like this. So the blue one would be our new graph. In example D, h of 1/2 x, well, looking back at our notes, we see that is a horizontal dilation. So we're going to be kind of stretching that graph horizontally. So when we put 2 in for x, really it's as if we're evaluating 1. Or if we put 4 in for x, it's if we're evaluating 2. So we're going twice as far for x, but we're really only as if we're going half as far. So that's going to change our plots. Our ordered pairs there look like 2xy, and we'll go ahead and plot those corresponding points. The easiest ones to do first are the intercepts. So 1 becomes an x of 2. Our intercept of 4 becomes an x of 8. Our negative 2 becomes negative 4. So I've stretched my graph. So even here at this critical point up here at negative 1, 5, now I double that, and that's going to be at that particular point. And this point down here at negative 3, negative 5, now is going to be out, or pardon me, at positive 3, negative 5 is going to be out here at 6, negative 5. So I'm going to move that point that way. I'm going to move that negative 1 over to negative 2. And now I'll be able to connect those points and sketch my new graph. So I'm sketching my point here. This point at 0 is still going to stay the same. And I'll sketch that, and I'm going to go through 2. I'm going to head towards my x of 6, and then I'm going to go back to my x of 8, and there is the blue sketch of my horizontal dilation. I've stretched that particular graph. And in sample E, y equals h of 2x, this is going to be a horizontal compression. So I'm going to squeeze this guy, because now I put 1 in for x and I'm doubling it. It's like putting 2 in. I put 4 in for x. It's like putting 8 in. So now I'm covering the cycle of the graph a lot more quickly. In fact, twice as fast. So my ordered pairs here, I only have to put in half of x to get the same y, is really what that means. So now I'm going to go and replace these points. So negative 2 becomes negative 1, and 1 becomes 1/2, and 4 becomes 2, and 3 becomes 1.5, and 1 becomes negative 1/2. So I've really squished my graph here, and then I can go ahead and do my best to connect my points on my horizontally compressed graph. And in sample F, h of x minus 1, well, that's going to be just a shift of 1 unit to the right. So that ordered pair is x plus 1 and y. So really, I'm going to take my whole graph and everything gets shifted 1 unit to the right. So the easiest ones, I'll take all my zeros and shift all those 1 to the right. And then my critical points here, shift that 1 to the right. And then I can go ahead and draw my graph. That's all 1 unit to the right. And there's a few more transformations of the same graph, and you'll get some more practice with this when I see you in class.